Okay, R4, factoring polynomials. As I previously stated, there is a video called Factoring Trinomials X Factor on the YouTube channel, and that shows you step by step how to take a systematic approach to factoring, so you're not doing a bunch of guessing and checking. So go ahead and check that out. What I'm going to stress here is just the special types of factoring. First, we're going to cover the difference of two squares. So if I have 9x squared minus 80, no, I don't want to do 81. 9x squared minus 36. Nope, because that's factorable either. Minus 25. I didn't want to pick those because actually 9 goes into those, and I could do something else which would work, but I didn't want to get into that right now. So what you're going to do here is you're going to factor these into two parentheses. One with a plus and one with a minus in the middle. Then you're just going to take the square root of each term. Square root of 9 is 3, so we put that first. Square root of x squared is x, that goes next. And square root of 25 is 5. And if you FOIL these, you get 3 times 3, 9, x times x, x squared. On the outside, you get negative 15x. The inside, you get positive 15x. Well, those are going to cancel. And on the end, last, you get negative 25. So it checks out. That's called the difference of two squares. So you have perfect square, subtraction, difference. Now, you could also have something like that doesn't look exactly the same at first, but I could have 16 x to the 6th minus 49 x to the 4th. Now let's make this y to the 4th, not to get too confusing. So I'm going to take my two parentheses, like so. I'm going to make one plus and one minus. And the reason I can do that is because 16 is a perfect square. X to the 6th is a perfect square, because you can do x3, x3. 49 is a perfect square, and y4 breaks down to y2, y2. So the square root of 16 is 4. Square root of x to the 6th is x to the 3rd. And we do that on both of them. X to the 3rd. Square root of 49 is 7. And square root of y to the 4th is y squared. And there you go. 4x cubed plus 7y squared and 4x cubed minus 7y squared. It breaks down. Okay, now what if I had something like this? So we got 16x squared minus 81. Well, everything's perfect, so I'm just going to break it on down. And it's going to be 4x plus 9 and 4x minus 9. Breaks down very nice and easy. Now, what if instead I had 16x to the 4th minus 81? Here you gotta be careful. It'd be very similar. This would break down to 4x squared plus 9 and 4x squared minus 9. But then I gotta look and say, hey, wait a minute. This one right here is also a perfect square. So this would break down to 2x plus 3 and 2x minus 3. That would give me 4x squared plus 6x minus 6x, and on the end, negative 9. So when I finish this, it actually breaks down to 3. So you got to be careful to pay attention to, after you do your initial factoring, see if anything else can be factored anymore. Now, there's also what's called a perfect square trinomial. And that's when you have something like this. You have perfect squares on the end here. And what you're looking for is this a perfect square and is this a perfect square? Yes, it is. And you look at the square root of this, 2, and the square root of this, 3. And if you multiply and double those, does it add up to this? Yes, it does. So therefore, we have what's called a perfect square trinomial. Here's a shortcut I talked to you about before. 2x times 2x is 4x squared. 3 times 3 is 9. Multiply 6x and double 12x. The only difference is if I would have had 4x squared minus 12x plus 9, the only difference is it's going to be 2x minus 3 squared. Because this is still going to give me 4x squared. Negative times negative will still give me the positive 9. Negative 3 times 2 is negative 6x doubled negative 12x. And that's called a perfect square trinomial. And that, along with the other video with the method on how to factor, is all we have.